Got it. By golly, stargazers alive. Here we are. Hello, everybody. Members of the club and other folks that are amateurs or professionals. We are about to do our 58th episode, ladies and gentlemen, of the SBAU Astro Hour. Baron Ron Heron is my name. It's a weekly blog podcast for the South Coast Longtime Telescope and Astronomy Club, the Santa Barbara Astronomical Unit. We're just starting to come back to life, from the pandemic with our third online general meeting Friday night at a grand time with a young man named Mirek Brandt, and doing this program for over a year. So we're into our second season. This is for April 4th, Monday morning, through, I guess, the 12th, which will be next Sunday. Got some headlines. This is what we're going to try to talk about today. Nebulas are us. We're the Pleiades and the Rosetta, or Rosette, or Rosette. I'm not sure how it's pronounced. We're tracking rogue planets these days, way out there. I don't know how they're doing that. No suns. Mars and Saturn are up before you guys, unless you set your clocks. And there's a state in the U.S., I don't know if we'll get to this or not. Has a state ever adopted an official astronomical object? I didn't know they did that, but there is one, and you'd be surprised which one it is. We got a couple of reviews to do. Friday night was wonderful, great. Got a good talk. Wasn't terribly long, or got a lot of questions. He enjoyed it. Mirek, Sean Kelly was on board. Any comments from anybody about Friday night's third general meeting? Mr. President, let's introduce everybody. Lower left on my screen, but they juggle them around, is our president, beloved Jerry Wilson. Hello, Jerry, whose wife is Pat Forgy, and he's in office because we have a plague going on 4 years. I'm right beside him. And Tom Totten is running the show. I'm on the left upper next to me. Tom, your wife, Suzanne, the artiste. Thank you for your technical wizardry. He's a former president and runs the web. Outreach coordinator, we couldn't do better than Chuck McPartland over in front of the Ukrainian flag. His wife is the merchandise manager. And I don't know if we solved the problem of the cup, but we're not going to bring it up. We'll talk about it at the board meeting this coming Saturday. What time is that? I got to run the show. I guess 5:30 or 4:30?
5:30. Yeah.
Okay, there is Bruce Murdoch at the bottom of my screen. He is married to Bonnie and president of the Theater Organ Society, and has a huge, how are you, Bruce? Got a huge telescope.
I'm doing fine.
All right. What did you do Friday night? You were out gallivanting around checking out stars?
Yeah, we went to the Las Flores Regional Park, Santa Maria Park, to do stargazing.
Okay, well, we had fun with that.
Had 110 people.
Is that right? Cold enough for you? Where is the global warming we're supposed to be? My God, it's global. What a humidity! It's getting really bad. We just lost our man there on headlines. We gave you those. You want to do some of the silly science cartoons that the president loves to send our way, Tom?
Yeah, run.
Okay.
Yes, Bruce.
See if I can find
one of them is run.
Yes. Oh, run. Oh, yeah. Well, see, I learned a long time ago, he can't necessarily find the one I call out. So we'll just match his.
We're going to go the latest one and go the opposite direction here.
You're out camping.
Oh, I like this.
Family, Dad goes, kids, you got to check out the stars. And they're punching it in, www.thestars.com. Some of these are not really rib ticklers, but they're interesting.
Here's your run one.
This is the good one. Hey, run like hell, man, run. Run. What happened to the dinosaurs is about like you could run anywhere, and avoid that incoming asteroid. Okay, grab something else. Oh, back at you. Shows what happens when you throw a boomerang pie. It's got to be shaped a certain way, but it got him right now. Oh, what happened here? Can you enlarge that?
Yeah.
Just read it off the screen. Seems there is a difference between a hypothesis and a guesstimate. I blew up at him. Okay, my God, that one I didn't put over on my list here for some reason. All right, on TV, these are not, this is not the funniest thing, but it is kind of an interesting comment on our time. New Fusion Mach 8 Occam's razor, ladies and gentlemen, now has octuple blade action, 8 blades for the closest shave yet. Hey, you know, Maud, remember when Occam's razor had the simplest solution, just one blade? I do remember those.
As many of you know, Occam's razor is a postulate that the simplest solution is usually the best and the right solution.
Occam means that?
Occam, yeah.
Occam.
It's the name of a person.
Yeah.
Oh,
And it's called Occam's razor.
well, my memory goes back to
This is a pun
Gillette.
on that.
All right. Anybody remember the Gillette double blade?
We saw that
Yeah.
one before.
Oh yeah, then they're now 5 blades.
Oh, easily. And this is, let's see, where is this one? Well, it's 3 views of the Dragon Nebula or Dragon constellation. Cosmology, astronomy, and astrology. Lord. Okay. We have some astrologers in the club. I'm not sure if they'll take kindly to that. I don't care. I like this one. The new names. We have Mercury, keeping its name Venus. Earth goes out to Mars, and Jupiter, Saturn. Let's rename that one Doug, and then Neptune, planet Doug. You know what I say?
I get it. I finally get it.
Yeah, Uranus
No one realized.
or Uranus.
Which one is? I think
What's better,
Uranus.
Doug or Uranus?
Yeah. Well, I'm going to call it Doug from now on. I'm sorry. Okay, that's
It's probably a mythological person anyway.
Yeah. Well, we got a lot to talk to this hour. You want to go out to the moon first? Planets to see at dawn. We need Whittemore on board. He's the one that goes out and checks out Mars and Saturn. Are they first tomorrow? Let's see. They'll be 24 minutes apart in the early morning sky, about 2 hours before sunrise. And they'll be 5 degrees high, climbing in the east.
And Jupiter and Neptune were just real close too, but you needed binoculars to see Neptune.
Yeah, I have their magnitudes here. It's kind of high for Neptune. Wait a minute. Oh, Jupiter is magnitude -2. Does that mean you can see it pretty negative?
Yeah, very bright.
Very easy. Yeah.
Okay, magnitude 7.8. That's above the limit of, I understand, is about what, magnitude 6 is where we can not see something but the nude eye.
Yeah, but it's that is in pretty good skies.
Okay.
Yeah, in a really dark sky with really good vision, it's like 6.5, but it also varies by people.
Yes.
But the big lineup we had was last week, wasn't it? In a row.
Still there.
Still there?
Yeah.
Okay. Venus and Aquarius. It's.
But you can get Mars and Saturn in the same field of view.
Is that right?
It's that morning though, right?
Yeah, just that morning at that time.
Okay.
Pre-dawn.
And it's Deneb Al-Jedi in Capricornus, magnitude 2.9.
Tail of the goat.
Mars sits just below Saturn, magnitude 1.1, while the winged planet is brightly magnitude 0.7. Is that right? Is it that bright? You can see
Yes.
Saturn?
Magnitude 7 is very dim.
It's 0.7.
What's that?
0.7.
Full form. Okay.
7/10.
Yeah.
So that means you should see it with the naked eye, but you can't see the
Sure.
rings.
You can't see the rings.
Yeah,
No, you
it's
need
just a
about
dot in the
30x.
sky, but it's very bright.
Yeah.
Okay, so the ancients could see Saturn, but they didn't see the ears until Galileo got his
Galileo.
scope. Okay. Still waiting moon lighting up Gemini. If you want to look north in search of Galaxy NGC 4449 in Kawes Venatici and his orchestra. The Hunting Dogs, magnitude 9 galaxy, covers about 5 arc minutes of the sky, has a high surface brightness with a rectangle shape. Really, that's best to use a large scope for this. Or is that what we're looking at?
No.
No, that's a planetary disk you had there for a minute.
Huh.
What was the name of the we're looking for there?
Still waning moon. This is still part of the water. Okay, I jumped into the waterfall of stars. I'm sorry, I didn't.
Oh,
Still waiting moonlight. Let's talk about rogue planets. You want to?
Sure.
We touched
Go
on
ahead.
Right.
that. Let me read
Well,
what
that Kimble's Cascade is really pretty in binoculars. So
Well,
And
you
that
were-
NGC 1502 is not a galaxy. That's another open cluster.
all right.
That's
well,
a guide to get there, right?
It's at one end of the cluster, yes.
Yeah, I
No,
mean,
but-
I can put in NGC 1502 into my go-to scope, and it'll take you basically there.
Yeah,
Right,
so
at
it's
the end
at
of the
one end of
waterfall.
the Cascade.
Why do they call it a waterfall? Does it look like it's pouring over or something?
Yeah, if you look at the picture, Ron, you can see it's a stream of stars.
Well, can you
Yeah.
throw it up again, Tom, or did you?
Yeah,
Hasn't
sorry.
put it up yet.
Kimble's Cascade, Father Kimble, Lucian
Trying
Kimble,
to figure out where we're at here.
Franciscan amateur astronomer. What was the year on this? It doesn't say.
There.
There it is.
Oh, okay.
See, it's a line of stars going from upper right to lower left.
Wow.
That's like Galley's braid.
Yeah,
So that's not a star cluster.
No,
it is on the lower left. That's 1502.
yeah, the lump of light down there.
Right.
Oh,
And you
really?
can see, this is a very well processed image, and you can see a dark nebula going down vertically from upper left down toward lower right with some, branches off of it. That way, and then there's extra dark place right there where Tom's cursor is. And that little area is completely devoid of stars. And there's fewer stars at different places along this dark nebula. So that's an unilluminated cloud. It's a cloud of gas that if there were a star in it, it would either be glowing blue or red, depending on its composition and how it's illuminated. So that's a nebula you can't see because it's dark.
And it's in the constellation Camelopardalus, the giraffe, not the
Yeah.
camel.
Spotted camel.
Wonder why they didn't make that the snake constellation.
We got a bunch of snakes already.
Yeah, I guess they did. with it.
Draco the dragon, yeah.
Well, Serpent's the snake.
Yeah.
Oh, yeah.
Have they counted the number of stars in that line at waterfall? 15 or so, right?
Yeah, you can count them there.
Oh,
It's like
yeah.
about 18.
Do you suppose they're close together?
I get 15 and not counting the real bright one in the middle, which I don't know if it's with that grouping.
Huh.
I got 16 if you count the one that's next to that nebula.
Oh, yeah, that way, yeah.
And it took a Franciscan priest to find it, Father Lucian Kimble. Wow.
It
thought he
says
was
that
Jesuit.
distance to that 1502 is 3,500 light years about,
Really?
and it's 5.5 light years in radius, so 11 light years in diameter.
So
It's
is it
small, isn't it?
part of the giraffe nebula or constellation?
It's in the constellation.
But it's not one of the, it's not the nose or the heel or
No.
the foot or something like that. Interesting, fascinating. What's the bright one in the middle? The bright star center?
It's a bright star in the middle.
Yeah,
Bright star, they all have names, I'm sure.
well, this one will have a large number of different numbers depending on whose catalog you're looking at,
Yeah.
but I don't believe it has a name.
Waterfall of stars, the stuff I keep learning.
Tim Crawford says that it always reminds him of a slow motion rock dropping into a brook below. I guess actually I think he's talking about 1502, the nebula. So
Well, and the stars as the rock coming down and then making a splash.
oh, okay. Yeah, it makes sense. Jim Williams is logged on also.
Okay. Can you find a picture of NGC 4449 and put it up?
Yeah, I think I do have one of those here. Let's see. Is that
I neglected to
it?
put one in.
Yeah, I'll get it. Okay, so that's what subject is that?
Yeah, I remember writing it down, but which one of my many departments is it in?
It's under Kimble's Cascade. It's right under the picture of Kimble's Cascade.
Oh, okay, 444. I have NGC 1502, easily visible. What's that?
That's the one on Kimble's Cascade.
Yeah,
Okay.
down the paragraph below the picture of Kimble's Cascade.
So this is an asterism again.
So just talking about this odd looking galaxy here.
Yeah, that's the one that Hubble took there.
That's a galaxy?
It's a galaxy, and it's classified as a Magellanic Cloud type galaxy.
Oh,
It's irregular. It
right.
does resemble the Large Magellanic Cloud.
The Large Magellanic Cloud looks like a barred spiral. It's got a very pronounced bar in it anyway.
Well, so does this thing.
Yeah, I know.
Yeah.
All right, I found it all. The hunting dogs area, let's see. NGC 4449, look
Yes.
3 degrees northeast, a magnitude 4 star, and the hunting dogs called Chara.
And Asterion is the other one.
Didn't get that listed. Magellanic, the reason it's called a Magellanic is that it's like one of our little orbiting galaxies of the Milky Way.
Usually it has its morphology appears to look like the Large Magellanic Cloud.
And what's the word Magellanic? Word that Magellan? Did he see that?
Clouds, yeah, the clouds of Magellan. When he sailed into the southern hemisphere, I guess he recorded 2 blobs of the faint fuzzies in the night sky. You can see them visually; they're very prominent.
Here they are in a picture.
Yeah, there's what they look like to the naked eye. That's
Right.
that's below the equator.
Oh, wow! So we can't see it.
Not from here, but you can if you go to Australia.
Can Australia? Can Australia see Andromeda?
Yes, barely, I think.
Yeah.
It depends where you are in Australia. Southern Australia, probably not.
But now we're going to suck these little ones in, aren't we? And Andromeda is just going to ram us. Is there a difference? We're all collecting together, aren't we?
Yeah.
You mean the Magellanic Clouds?
All of them.
They're orbiting us.
Isn't there one?
We've already stripped them of most of their stars, I believe.
Okay. Wow, that's taken under the equator. That's Australian topography we're looking at in that
It's
picture.
Atacama Desert. It's Chile.
Yeah.
Oh, it's Chile. Wow. Fascinating stuff. And the waxing moon lighting up Gemini is happening while we're looking for NGC 4449. Good stuff.
Mhm.
Well, you want to go to Protostellar Discs or check out
Yeah.
Rogue Planets?
No, let's do spirals and protostellar discs. That is, stars are forming and the planets are forming out of the stellar disk, the disk of dust and gas that's orbiting them. And this was one of the things touched on by our recent speaker.
Oh, Friday night or a month ago?
Friday night.
Oh, he touched. Oh, you mean the star that's wavering and doing a waving track? And that's how we know it's got a big planet around it.
No, he showed some circumstellar discs and how things form. So he was
Yeah.
talking about the formation of brown dwarfs,
Mhm.
and whether they form from direct collapse or from accretion processes.
Okay, well, here's what the notes say from Jerry: a pattern caused by a density wave that spirals out from the edge of the galaxy's disk. Now we're going inward, right, to the center and back out again. Oh, there's our man. Thank you.
Yeah, that's where the spiral arms of a galaxy come from. And you see spiral arms also in the protostellar discs, these where planets are forming. It's different mechanisms, but they both have arms in them.
But this is not like gravitational waves.
These aren't gravitational waves. Well, they're not. Yes, they're not gravitational waves.
But they affect the stars, make us jiggle, or we get.
No.
These
No,
are
Ron. No, the wiggling of the star was caused by the gravitational effect of a planet orbiting or a brown dwarf orbiting around it. This is entirely different. This is the formation of those objects.
Well, yeah, but I was just commenting on what Jerry just said. This is how the arms are made. Somehow these waves collect the stars that would have to make some of them move together into the arms. We're in a little spur, right?
That's in a galaxy. That's in a galaxy. This is a protostellar disk,
Oh,
protoplanetary disk.
got to get the difference here. Stellar traffic jam is what you called it.
Yeah,
Or
but
what
this is more like a gas traffic jam.
Planetary rings like Saturn, protoplanetary discs. So virtually all stars started that way, with a bunch of gas swirling around like a hurricane.
They form out of nebula, and certain turbulences in the nebula cause localized concretions or concentrations. And then those gravitationally attract more dust, and you get a dark object forming called a Bok globule that's going to be the star and the planetary disk. It starts condensing, and the middle part of the stuff starts condensing and heats up, and it heats up until it starts fusion, and then the radiation starts blowing the disk out, the dust away. And turbulences in the disk will later form planets.
Okay, so
That's
we
a
don't.
simplification, but that's it. So the differential rotation of a galaxy is what forms the arms. So the galaxy rotates in a way that the velocity, due to the missing mass, Zwickie's missing mass, the galaxies rotate with the same velocity from center to outer edge. The edge is not going a lot slower, but because the edge has a longer distance to go, it takes more rotation or more time for it to make a complete rotation. The inner stuff traveling at the same speed can make a rotation around the center of the galaxy much faster. And this causes bunching of the debris in the galaxy, the stars and the star clouds. And that's like a traffic jam working its way backwards through a concentration of automobiles on the freeway. And that's where you get the spiral arms in the galaxy.
And usually it's either 2 arms or 4 for some reason.
Yeah, yeah.
Do they have any out there, galaxies with a whole bunch of arms, 12, 18, or can you count them?
I think I've seen a picture of one that they said they traced 8 arms.
Yeah.
Huh.
Octopus.
We have what, 2 major arms in ours that come off of our central bar, but there's a lot of
changing. 2, 4.
What's that?
That keeps changing depending on who does the measurements. Sometimes now they think that our Orion spur is part of a major arm. So I've seen 2 or 4 for our galaxy.
Yeah, but that's where I was going with this. So thanks. We have 2 major arms, but then we have lots of small sub arms and armlets and streaks. Just like the picture in the upper right corner that. Oh, that's the one you're showing in the middle too. Yeah. Oh, stay with that. That's the current thinking on ours. So it's 2 major arms, but there's other sub arms going around. So I don't know where the borderline between an arm and a sub arm is. So this, as Chuck is saying, this could have 4 or more.
Huh. And the bar turns as well.
The thing winds up. In this case, it's winding up. It's spinning. The central disk is spinning clockwise in that.
Huh. And that's fascinating.
So how come the bar doesn't get spread out?
It's the same reason that the traffic jam, it runs up and collides with the cars ahead of it, and it takes time to get through that.
But there are galaxies that don't have a bar but still have the spirals, right?
Yeah.
Do they know why some galaxies are barred and others aren't?
I don't know, referring to they, but I don't know.
Okay.
And you've got elliptical
theories
galaxies.
kicked around. We are a
arms.
barred galaxy.
Lock
Milky
up.
Way, are we not?
Seems like it
Hey,
might be
Tom.
locked
Yeah,
up.
that
here.
makes sense. Everything's going the same speed. It's just they got farther to go outside on the edge of the track. Fascinating stuff.
Hello, Tom.
Oh, hi. Morning. Sorry I'm late.
More with us?
Okay.
All right, just let it happen.
We're now complete.
Missed you earlier, Tom Whittemore, on checking out the planets of the night sky, or the morning sky anyway, but maybe we can.
Were you up looking at it this morning?
What's that?
Were you up looking at the morning planets?
No, not this morning. We had to take little Wally into the vet. So,
Okay, but you didn't get your second booster shot and then go sleep it off, did you, like the other two?
no, that's, no.
That's apparently what's happening to us. I haven't got mine yet, but we'll see how that works.
Mm-hmm.
Talking about galaxies in the Milky Way now, interesting figures here, Mr. President. Takes our galaxy 200 million years to do a complete revolution, and we've done it several dozen times.
If you're, yeah, for the outer edges to make that trip.
But what I understand is that we're going to be in an arm someday, right? We're now out of an arm and a spur, but those arms kind of go through the stars. Is it fair to say?
Yes. Yeah, a star doesn't stay with the arm. The arm is a density wave that moves through the collection of stars.
Right.
Just like a density of a stop and go on a freeway that moves through the cars.
Would it be fair to say that most of the stars we see in the night sky are in our spur, or are we looking into an arm one way or the other?
I think we're doing both.
Okay.
Yeah.
There it is. Oh, no, that's not a bar.
Yeah, but we're not in the bar.
No, but I thought that it was our galaxy. What is this we're looking at, Tom? Star
Well, here,
formation,
this is
The generalization.
Protostellar.
So
Okay.
it's 4622.
And you can see here the direction of rotation. Oops, Tom went off of it. The direction
yeah,
of
goes this-
rotation is kind of opposite what you'd expect. If you go back to that previous one.
Yeah, go
yeah, if I
back.
can find it. It's kind of strange.
Well, that's got to be clockwise, I would
If I
think.
can find it. Which one had it?
It's right below the big one.
Below the
No,
big
that
one?
wasn't it. It was like NGC 4462 or something.
4622.
No.
Yeah,
Sorry, I can't.
it's
Having
right
trouble
there at the
finding the
top
one
of
that
your
It's right in
showed-
the middle. Oh, right, upper top, up there.
Sorry.
Okay.
See
Which
the
one?
row? It's right in the middle, the kind of yellowish one. Yeah, either one of
Okay.
those.
Yeah, there you go. Okay.
There.
No, well, click on the one in the middle of the top row. There we go.
There you go.
Okay, look at the direction of rotation there. See, so it's that one is counterclockwise
Yeah.
or clock.
Oh,
I'm sorry,
that's
it's rotating
clockwise.
clockwise, but from looking at the arms, you would think it was going
Yes.
the other way.
Yeah, the arms are not the way you'd expect them this time.
Really? Why?
The density wave isn't a physical thing, so just depends how it gets started up, I suppose.
Yeah. Yeah.
Direction of galaxies going up.
Rotation.
I've heard you
That
say
is
that
strange.
before, gentlemen. That is crazy.
Yeah,
Because,
good illustration.
What?
I said good
Okay.
illustration.
Is it a similar
There's an arrow.
phenomenon? Is it a similar phenomenon to hurricanes? What makes a hurricane form in one direction in the northern hemisphere and another direction in the southern?
No,
they-
well,
No.
I mean, it's all conservation of angular momentum, but no,
That's-
it's not Coriolis forces.
Right. You're not on a
Yeah.
curved surface.
The hurricane thing is Coriolis forces in action.
Okay.
If
But
you
the-
blow up that graphic or that picture, you could see a red arrow on that says the direction of the galaxy's rotation, which is clockwise. But by looking at the arms, you would think it's counterclockwise.
Yeah, you would. That's crazy. All right. What do they call the galaxies that are just big cotton balls that aren't in a flat disk, that aren't rotating?
Ellipticals.
Sounds like
Elliptical.
What are the stars doing in those? Do they know?
It's random orbits. They're just like a swarm of bees, like a globular cluster.
Yeah.
Had to have a lot of collisions, I would think. This is
It
more
will
organized.
eventually, over very long periods of time, it will eventually form a spherical structure with everybody marching in the same direction. And then it will collapse into a disk. And
Okay.
it may have been in that same position long ago, but it collided with something that perturbed all its motion into this randomness.
Spiral Galaxy NGC 4622. They don't have a regular name for it, I guess.
That's
These are all
this what you're showing now is a very early classification scheme. I remember seeing that when I was a kid. It's not considered the way things evolve nowadays.
The tuning fork.
Yeah,
Right, that's the tuning
fork
fork.
picture.
Well, Dr. Dervish is going to subject this as his topic on the 6th of May for our next general meeting, evolution of
Excellent.
galaxies.
I look forward to that.
Oh, great.
Fantastic. Edwin Hubble.
But this is
What
the, stay with this, Tom, don't change the picture. But
Okay.
this is also how a random cloud of debris, say our solar system before the star formed or shortly after the star formed. Tom, would you go back to that picture, please?
To the one that you provided?
No, the one that you just had up there that
It's in the upper left on
had
my
the
screen.
tuning fork.
Okay. That's one. You see it?
No,
No,
You don't
there.
see this?
No, that's not it. But go back to the other one.
Okay.
the Edwin Hubble one.
The hub, yeah.
Your little arrow backwards doesn't work?
It's all on the same page here.
There you go. Stay there, please.
Hmm.
So you start over with EO, and that is any spherical collection of gas. Everything in there is random. And then through collision, they all average out to a certain spherical collection, but they're all rotating in pretty much the same way. They lose their randomness because they collide with each other. They don't actually have to hit each other. They just have to come close and gravitationally interact to uniformize their motion. And then with that, they have no resist because they're all moving now with one angular momentum. And to generalize, they have no resistance to gravitational collapse from a sphere to a disk. They can only,
In the perpendicular direction.
right, in the perpendicular direction. They can only resist collapse in a lateral direction. So that's how you get a disk out of it. And that has occurred in our planetary system here, in the solar system, for the inner planets, and they formed disks. They formed a disk with knots in it that became planets. Would you please go back to that, Tom?
Sorry. Where's Hubble? It's right here somewhere. Where'd that one go? Dang it, it should be right here.
Well, Edwin.
Oh, maybe it's right here. It's right here. It's right here. Okay.
Mhm.
Okay.
There. Now, and that would be like, and that progression of collapse to a disk has gone beyond our planets. Now it's out in the Kuiper belt. Now we have a Kuiper belt that it's less dense, so things happen on a slower scale, but it has also collapsed into a disk. And then we have out farther out, so the Kuiper disk would look like E7. But then we have also out beyond it, the disk is so tenuous, the ball of rotating mass is so tenuous that it hasn't had time to do the collapse, and it's low density, so things move very slowly. So the Oort cloud farther out is still spherical for us.
The bubble.
And this diagram of Edwin Hubble is that logical progression extended to the idea that galaxies start from a random collection of stars, and they go through this same process of equalizing their angular momentum and then their collapse along in 2 dimensions to a disk. And then the disk starts forming traffic jams of different types. So the 2 branches that he has out here is the bottom one shows bars in the middle and the other one shows no bars, or else short and you can't find them bars. But it's the same progression, and that's where this diagram came from. But I think my field was not astronomy, but I think they have there's been a different view of it from the original Hubble diagram, which to some extent,
originally, this was his evolutionary diagram, thinking they started out as ellipticals, and then that spirals were more refined galaxies, later age, and
Right.
it's just they're not connected in that way.
Yeah.
Right.
Well, what's the main difference between the two prongs on that fork, that tuning fork? The upper,
Bottom line is barred spirals.
oh, barred. And the top don't have bars on the top. So we're in the bottom.
Correct.
Well, what does the single line on the left mean?
Those are the elliptical galaxies. He thought that they began that way and they progressed to spirals.
Oh,
Yeah, time progresses to the right.
I see. Gotcha. Wow. But there are some globs out there. You showed a picture of one while ago that's not organized at all, aren't there?
That would be one of the EO, E3 type things.
Oh, I see. All right. Wow.
Okay, well, let's go to a rogue, a pair of rogues off
Oh.
to see the world.
All right. There's one rogue long ago escaped its home stellar system, you write. May not be alone. Oh, my God. How in the world are we seeing a rogue from this far away?
Well, we're not seeing them. They're inferring this to be the case from data. These pictures are drawings, artist renditions.
Can you rattle off the name of this sucker, Mr. President?
Oh, yeah. Oh, yeah.
Two mass J11193-254-1137-466.
Kind of rolls off your tongue, doesn't it?
Yeah,
Yeah.
just right off my tongue.
Jerry, I think
It's
they
stuck
actually
in my
did
teeth.
image these things
What?
with the Keck telescope.
Now, they're not brown dwarfs, but they're super Jupiters, aren't they?
Yeah.
And they think there's two of them, not just one.
Yes.
And so they'd be rotating around each other.
They're now called that same thing you rattled off, but A and B
Oh,
added on, which you can see under the caption of the image. So they're about the center point. They're in a TW Hydra association of stars, which is a grouping of stars with a center point about 95 light years away. These two rogues are about 160 light years away, and they're believed to be part of that association.
So they don't orbit each other?
But they orbit each other apparently.
Oh, really?
At first, they don't orbit a star. They are just off on their own. Probably pretty cold up there.
The
yeah.
fact that these are red, doesn't that imply they're brown dwarfs?
They're too light to be brown dwarfs.
Huh.
They don't have enough
Not
mass,
enough
but
mass.
they're
Yeah.
still giving off infrared radiation from gravitational collapse.
Right.
Okay.
So they're in the as it says, they're firmly in the planetary range rather than brown dwarfs. So
I don't know about you, but I get my news from Fox News. So here's here's an image, I guess, that was taken by Keck.
oh yeah,
They're calling them failed stars.
yeah.
Oh, good. I like that.
That's a better image. I didn't find that.
And then this other thing, they're somehow analyzing it, I guess, on this other, where'd I get this from?
Yeah, good job.
This was from who is this? AAS Nova, American Astronomical Society. So they got that the artist impression, then they got the TW. What's TW High? That's the name of a star, right? TW?
Oh, that's an association. Well, there's probably a star involved.
Yeah, it's a variable star in Hydra.
Right.
TW
And then
Hydra Association.
You can call it a very loose open cluster.
But yeah, this Fox News article had the image evidently.
You
that
weren't
was
joking
taken.
about Fox News.
No.
But at least it came from the AAS and not their infotainment division.
Yeah. Well, the whole thing, the whole operation is an infotainment.
Yeah.
They're not registered as a news outlet. If you watch, who is that guy? David Muir, I think on ABC or CBS.
Yeah.
One of those things, they lead into his evening news by saying it's the most watched news show on television. Now, Fox News has very high ratings, you know, but they're not a news show. They're registered with the Federal Communication Commission as an entertainment show.
Interesting.
Much like Saturday Night Live is for the left.
They could still be sued. They have been sued, as you may know. They may be paying out a lot of money from the voting machine companies.
Yeah. Anyway, let's not drift off onto the spiral arm of politics here.
More like a black hole.
Yeah.
Does science know where these two giants, these gas giants came from? Or are they originally around a star, or just happened to be?
I'm going to guess they formed around stars, or else they were their own gas cloud and they formed, but they just didn't have enough mass in it to become stars.
Well, that's something.
Either way is possible. They could have been around a star and some other planet approached them and gravitationally perturbed them to send them on a hyperbolic orbit out of that solar system.
Or a passing star, for that matter.
Yeah, or a passing star. That would be another gravitational hyperbole or attraction. The planets in our solar system apparently were not in the position that they're in now when they formed. There were more of them, and it's suspected that some of these have been flung out of our solar system, and some obviously have had collisions, like Theia and the Earth, to produce the moon. So even a planetary system is in very long terms. They're not necessarily stable when we see them.
But these protostellar discs you tell us about, they don't always result in a star firing up and getting lit in the middle. Sometimes they're just a big brown dwarf with a bunch of cold planets going around them, I would think.
Yes, that's true. Or it's a bunch of planets just going around each other. It depends on whether they had a central concentration that was massive enough to start fusion or not.
Yeah, what is our sun, like 99.9% of our solar system's mass? Is that right?
Yeah.
Mm-hmm.
Well, I've heard these planets are just Jupiter plus debris.
The planets, yeah.
There's some gas giants and there's some inner debris.
Yeah.
But there's also another way of looking at it is there's the sun and various debris.
But I've also heard that there's rogues going everywhere. They're everywhere. There are millions of them. We just can't see them.
Could be. The particular ones that we started talking about, those were believed to be ejected from a solar system and not forming that way.
Might have happened to us.
Could have. We could have a Jupiter out there somewhere that left home.
Planet X that we're looking for out of the Kuiper Belt or wherever it might be. Wow, that's fascinating stuff. So we may have rogues on the road, millions of those. We may have black holes everywhere that we can't see. And the only two are those that we just spotted, those rotating.
Yeah. When they first came out with the Star Trek TV show, they would go into, warp drive, and they were traveling faster than the speed of light. And they showed these stars going by and stuff. It wouldn't look like that, but I always wondered, what is out there? Space can't really be that empty at that speed. There would be dust clouds in it, and if you went through a dust cloud at the speed of light, I mean, it would erode the outside of your craft away right away. I don't think that it's engineering feasible to build a craft that, if it could go that fast, would get you anything. You'd run into something or a lot of little somethings.
Well, they go with big magnetic field barriers around them sometimes.
Shields?
Yeah, but a neutral object would come right through that.
Yeah.
Oh, it's not metallic.
If the dust isn't polarized, doesn't have a charge on it, it's not going to be affected.
That's why we needed a wormhole. Thank you very much.
Well, that's a question. Are wormholes bi-directional or only have a single direction to them?
I think wormholes are hypothetical.
Yeah.
Ask Jody.
You can have whatever you want.
Yeah.
Exactly.
Fun stuff, man. We're talking about stuff I never heard of. Waterfall of stars, rogue planet, galaxies like the Milky Way, spiraling protostellar discs. So just about all of them started as a protostellar disk.
This is one of the, what's I got up there now, the Rosette Nebula is a very stunning object near Orion. And it's a big object, it's easy to photograph. You can see lots of little structure in it, these little dark veins in it. And some of those, the ends of the dark veins are extra dark. And those are what, I forget his first name, but Bach noted at these as concentrations, and it's been called Bach globules. And those are where the gas is collecting, is condensing to form a star system.
It was
Yeah,
Bart
Jerry,
Bach.
it's Bart Bach.
Bart Bach, yeah, that's right.
At the U of A. Yeah.
And they're star nurseries, basically, things like
Yes. Yeah.
Mhm.
that.
And this one has burned as formed a star cluster in it of stars, and the stars, stellar wind is blowing the dust out and clearing out a cavity in it.
Hmm.
So this one is not only forming new stars that are very early, pre-born, pre-fusion, but new stars that have the fusion going, good hot blue stars, and they're blowing the nebula away. So that will eventually stop new star production and result in a star cluster.
Is this the
You can see how
Rosette here?
these-
Yeah, this is the Rosette.
Yeah,
you can see
there
how
was a
these
guy
Bach-
who was, I was gonna say there was a guy in our club up north, the San Jose Club, who moved to Arizona to one of those Astro communities. And in that community, you could see the Rosette naked eye. It's so
Yeah.
dark. Yeah.
And you
Really?
can see how those Bach globules kind of are pointing in toward the center. That's because they're being
Mhm.
eroded away by the stellar winds coming from the center.
Yeah.
Right.
When we went to the Hollister Ranch, what, 5 years ago or more,
Mhm.
Chuck, you were there, and they had
I
turned
was
out
also
all the
there.
lights, and I could see Andromeda, naked eye, all of it, including
Yeah.
the dust. It was just eerie. I mean, I got goosebumps.
Huh.
So we can get those kind of skies here if you get in the right place.
We
My
can.
backyard.
But now that's just a collection of gas that happens to be in a circular form, or is it the remnants of an exploded star we're looking at?
Well, that's a
No,
good question.
It's not remnants.
That's
It's probably primordial hydrogen mainly.
Mhm.
it sure looks like the remains of a supernova, doesn't it?
This thing is gigantic, Ron.
Yeah,
Huge, it's huge.
Oh, it
it's
is.
got way more than one giant star's worth of dust in it.
Okay. So that's how
Yep.
everything used to be early in the universe, and then the galaxies started farming around those. Wow. Where is the other, let's see, NGC 2244 is nearby. That's an open star cluster.
That's the star cluster that's in the middle of that.
It's in the middle.
2.2 degrees northeast of magnitude 4 epsilon monocerotis. Monocerotis.
Wow.
I had that once. I got a shot for it. Monocerotis.
So Ron,
You get that as a teenager, right? The kissing disease.
Ron,
Yes.
monocerotis, Latin.
Oh, of course. Well, I
It's the
don't.
unicorn.
It's from the unicorn, correct, Chuck? It's the possessive case of
We have a-
monocero.
We don't have a unicorn as one as the 88 constellation.
Yes.
What we do.
Yeah, that's
This
we
is
do.
that constellation.
yeah.
There's a horse and a horse with a horn on his head out there. I didn't know that.
There's a horse's front end.
There's
Right.
also a little horse. There's a big horse and a little horse.
Uh-huh.
Yep,
And Monoceros is the entire unicorn. It's not just a half animal.
that's right.
Rhinoceros.
Yeah, mono, one, ceros, nose.
Or
Or
horn.
I'm sorry, horn.
Yeah.
One horn.
Uh-huh. All right, after sunset, gentlemen, just for the record books, it's in Monoceros, 50 degrees high in the sky, southwest. And this is another view of it.
Yeah, it's more or less around a winter constellation. It's a winter constellation.
Wow. The Rosette, do you know where Rosette came from?
Looks like
That's
a
from
rose.
the appearance of the nebula.
Yeah,
Oh, like there are such
Like a
things.
rose.
like a rose, yeah.
Yeah.
A little
Only a
rose,
road.
except it's a really big rose.
Mhm.
Well, I believe it's also known as Caldwell 49.
That sounds right.
Yeah,
Okay. Fascinating stuff, gentlemen.
Yeah.
The Caldwell catalog was started by, who was it, that English astronomer who was so famous in the 20th century?
Oh,
You talk about the fellow who loved the moon?
yes.
Oh, Moore?
Moore.
Yeah, Patrick Moore, yeah.
Yeah,
He started his own catalog, but it would have been another M catalog. So he called it the Caldwell catalog, which was his middle name.
Right, and all of these objects are mostly associated with NGC objects, okay? One example is Caldwell 1. It's the closest cluster to the Polaris. It's also NGC 188. Easy to see, nice one. Hey, Jerry, I know I came in really late. I was wondering if you had covered the Kimble's Cascade.
You did.
Okay.
Yeah, we did.
You want to go back and make a comment about it? Go ahead.
Something about it. Instead of camping in southern Utah. There it is. And you can see NGC 1502 there on the left, which is, of course, an open cluster. There's also a beautiful planetary cluster, NGC 1501, okay, that it's not in this particular picture, but what this always reminds me of is camping in southern Utah, and also looking up, kind of like midnight time, and then looking up towards the north and just seeing this absolutely incredible jumble of stars looking like a waterfall. Best viewed in binoculars. This is an incredible image you got, okay? And then I always think of as the stars as a falling water flow, and then the splash is 1502, that little open cluster on the bottom. It's really pretty.
Uh-huh.
And it was named by a Canadian priest. You probably always said that.
Franciscan. Thought the Canadians
Yeah,
were.
it's a spectacular object in this wide field of view scope.
Wow.
Yeah. So Jerry, you'd be happy to hear what I've been doing lately is I put down the binoculars and I brought out my Tomback 92 millimeter triplet. And I've actually been putting that on a Gemini G11 mount and just looking at these bright things. It's been a lot of, I've been away from the motors and stuff for a while because I had those at Westmont, but now I roll it out here in the backyard and I can look at these things with a small telescope, 92 millimeter.
So we should explain that these stars with the lines in them are exploding stars. That's why they have lines, right?
No.
You do watch Fox News, don't you?
Yeah. And Tom, if I wouldn't mind injecting this here, we're going to have some folks visiting the Westmont Observatory. You probably already know this in May, and it would really be fun. It's going to be a daytime event to put the C8 with the solar filter on it up on that pier. And if you have those bolts, I'd be happy to get you, to help you put those darn things in so we have that wedge back there again.
Yeah, sure.
So just let me know if you want, put it together and I'll go out there and open up the observatory.
I can't remember. Do you have that? Well, the problem is it's on a Monday, so we can't do it.
Oh, I have keys to the observatory, Tom.
Yeah, I'm gonna miss the talk that day because I'm gonna be there with an H alpha scope. We should get some more H alpha scopes.
Yeah, I think
really
we can probably cancel the show for that Monday and do that instead.
Yeah, take a break.
Or we could do the show from outside.
That's a possibility.
No, I
Good
forgot
connection.
that is a Monday, Chuck. You're right. That's a Monday. Yeah.
My iPad will do this show.
Do you know how many kids will be there from physics from high school?
Yeah, I heard on my email 20 to 40. They're from
good.
Santa Barbara High School, and I think they're AP students. And I think they're going to be on campus most of the day. And Chuck had an 8:30 time.
Well, I said 8:30 for setup because the email said they'd be there from 9 to 3.
Okay. So what they're going to be doing, as far as I know, Chuck, and I'll always put you in touch with the fellow that got in touch. I think his name is Ben Carlson.
Yeah, he was on email.
Yeah. So they're going to be basically going from site to site on campus, seeing lots of different things. So that should be a lot of fun to show the kids the sun.
Yeah, the question is whether we're getting them in little tiny groups all during the day or if they're going to come in one lump at some hour.
Yeah, I'm not nuts about a 6-hour outreach, are you?
Yeah.
Well, let's take the last 5 minutes of our show to talk about the variable star of the month.
Fabulous.
Arleonis.
Yeah, that's a beauty.
Arleonis.
Arleonis. Now, the reason that this is such a interesting star to me is that it goes from being magnitude 4.4, or I guess even 3.5, to magnitude 11, which is well beyond the range of visible.
Yes.
So it's quite noticeable. And right now, I guess at the end of March, it's at its peak brightness, so you'll be able to see it visually.
Yeah. And bright is up.
It makes it a mirror type variable.
Yes, it is. Yeah. In fact,
I
you
call
can
it Myra, but yeah.
Yeah. I always do.
R tells me that it was the first variable star cataloged in Leo the Lion. Okay, that's how they name these things. May I make a comment, Jerry, on this?
Of course, go ahead.
Yeah. I was going to say the swing in magnitude. You have to keep in mind that the swing in magnitude is, numeric, but the swing in brightness is logarithmic. So if something goes, for example, a swing of 5 counts, that's 100 in brightness. That's like comparing a 1-watt light bulb to a 100-watt light bulb. This thing is swinging around 7. So that would be 100 times 2.5 times 2.5, okay, which would be, I guess, roughly 700 times, a swing in brightness of 700 times.
Yes, it's a very spectacular change of brightness.
Yeah, that's an amazing.
630.9.
That was on the tip of my tongue. Thanks.
And why does it do that, gentlemen?
It's expanding and contracting.
Is it?
They think there might be a planet going around it that's evaporating, so that's why it's not.
Wow.
So Ron, hey Ron,
Yes.
trivia question. See
Okay.
the brightest points there on the top?
Yeah.
Is the star the biggest or the smallest at that point? This is for Ron.
Biggest in size. It says it's
Careful.
red giant. You're going to tell me it's the smallest, aren't you?
Yeah, when it's brightest, it's smallest and it's contracted.
Oh, I see. So it fires up.
Okay, so it's oscillating, huh?
Oh God, yeah. Oh yeah. That's breathing. That's an atmosphere that's breathing. And it looks like it's single component, so it's just going in, out, in, out, in, out, radially.
And it's another Betelgeuse.
No, I think it's a big carbon star.
Says
Late in
it,
its life.
that red giant in Jerry's notes. Late in its
Okay.
life.
Okay.
Yeah, well, Betelgeuse is a red supergiant.
Yeah, there you go. Thanks, Chuck. Thanks for rescuing.
Betelgeuse is not a variable. It doesn't fluctuate.
It is a variable. It is a carbon star, but it's a supergiant. It's much larger.
Oh.
Yeah.
Well, is this sucker Arleonis inside one of the 88 constellations? One of them?
Yeah,
Part of
Leo.
Leo the Lion.
It's in Leo, Ron.
What
Ron,
part?
everything is in one of the 88 constellations.
Yeah, there's no leftover territory.
Yeah. Jerry, my guess is this would be really pretty in my little refractor, like a nice
It's
red
right.
dot.
Huh.
I'll call it up this week because Leo is in good form right now. It's up nice and high.
Yeah.
Well, my
Wikipedia says a guy named Wiesenminer proposed, that was in 2009, that it was quasi-periodic fluctuation observed, might be due to the presence of an evaporating substellar companion, possibly an extrasolar planet.
Golly, Bruce, you just answered a question I was about to ask. Since more of the stars up there are in doubles or triples, how many
About half of them.
variables? Yeah, how many of these variables have a partner? Fascinating stuff, gentlemen.
Yeah.
Oh, here's a nice explanation of the size and the fluctuation
There
in
you
the
go.
brightness.
Mhm.
Huh. But none of
Yeah,
this,
that's actually really nice.
none of this expanding and contracting is going to be ending with a big explosion, turns into a nova.
No, it's a red giant.
It's a red giant, so it won't do that, Ron.
Red giants don't supernova.
No.
Yeah, and you have to be very patient, Ron, with these kinds of stars because the variability is on the order of a year.
So you don't think we're going to live long enough to see them? This one goes about a year almost, right? 300.
Yeah, but most of the Myra types are year, roughly year, 300 some days.
Yeah.
We happen to be on a bright section now. Next one will be January of 23.
Well, thanks, Jerry. That's really good information. That's kind of neat to know. I'll see if I can pull it in this week.
Okay.
That's a
There's
Harvard.
a finder chart too, which Tom can go to. I put in there.
Yeah.
It's not
This is-
marked. I was surprised it's not marked in my planetarium software, but I transferred it from another diagram.
That article that was up that Tom had is from the Center for Astrophysics at Harvard. So if you want to go find that.
Okay. Okay.
Fascinating.
Yeah, there's where it is.
So it's really close to Regulus, you know. That'd
Yeah,
be a
this
long-
Leo is a different drawing than what I like. I like there to be a straight line from Cherton to Regulus and then on out to this other bright star out here, which is the one. And then just off of that, the paw, that's where our Leonis is.
Mhm.
And nobody knows who R. Leonis was.
R. Leonis, Ron, means it's the first variable star found in Leo the lion. That's the Leonis, belonging to Leo.
And it was found by Ron Leonis.
Yeah.
So Ron, the way they name these stars, they start out late in the alphabet. First one R, then S, then T, all the way up. Okay, and then they go back through the alphabet. Okay, so this tells me this was the first cataloged variable star in Leo the lion.
So is there a T. Leonis out there and an S. Leonis?
Yep. Oh yes, I'm sure there are. Mhm.
We'll talk about them next week, maybe, or in the future. Meantime, next week is our board meeting at 5:30 at the Palmer Observatory. You want to come join?
That's on Saturday.
Yep.
It's Saturday, followed by the Star Party, right?
Yes.
Okay, and then the third Friday of the month is going to be Westmont.
Yes.
They're
Mhm.
out there with the TV guys. And
It'll be
their
the 15th, Ron. That'll be the 15th of April.
15th of this. Okay, we're sort of back on track, and I've got some interesting people to talk to us in the future. It'll be a Caltech professor, Dr. Ben Dervish. talking
Wow.
about-
Ron, send that information, his background to me.
Okay, well, I don't have much. Joe Doyle can probably tell you more than I can. He got me the guy. But we're going to have fun in the mornings on Monday. That was number 58. We'll do number 59 next week. You guys take care of yourselves and your tests.
All right.
Those of you who have electric. And we'll do it again a week from now, right after the weekend party. We'll have something to talk about. Thank you and Godspeed, everybody. Thank you very much.
All right,
Yeah.
thanks, Ron.